Hi friends and neighbors, welcome to the fourth ShepNotes video on a series covering statistics and probability. This video will look at sets, which are an important concept that must be understood in order to work with probability and statistics. Let's start by looking at sets for statistics and probability. A set is a well-defined collection of objects such as the names of the states, the list of phone numbers, and the infinite set of pixels that are used in the monitor that is displaying this video. The possibilities are endless. Each object in a set is called a member or element of the set. A set is usually identified by capital letters like A, B, X, Y, or Z. The objects or elements in the set are represented by lowercase letters like A, B, X, Y, and Z, numbers like 1, 2, and 3, or even symbols like the spades, clubs, diamonds, and hearts of a deck of cards. Now let's see how we can describe a set. If a set has a finite number of elements, these elements are listed within the braces and separated by commas. For example, A can be equal to A, B, C, and D, or B can be equal to H and T, or C can be equal to T and F, or D can be equal to 1, 2, 3, 4, and 5. An interval like -2 is greater than X is less than or equal to 5 can be indicated by open parentheses -2, 5 closed brackets, where the open parentheses indicates -2 is excluded and the closed bracket indicates 5 is included. Now we will look at how we can describe a set with rules. The set of all numbers could be described by the formula at A, which is read as A is the set of all X such that X is odd. A rule can also be a formula like the one at B, which is read as the set of variables X and Y, such that X squared plus Y squared plus 4 lies on the boundary of a circle with a radius of 2. The symbol for indicating a set belongs to another set is shown at A. Two alternate symbols that are often used to indicate that one set belongs to another is shown at B. The symbol that indicates that one set does not belong to another set is shown at C. If A is a subset of B, then B is a superset of A. The symbol for this is shown at D. Let's examine an example that states the relationship between some sets and their contents. The symbols for indicating whether or not some elements belong to others are summarized at A. An example of the use of these symbols is shown at B. Set A has the elements 2, 4, 6, and 8, and set B has the elements 1, 3, 5, 7, and 9. As stated on the last line, 4 is a member of A, 5 is a member of B, 1 is not a member of A, 6 is not a member of B. Two sets are equal if they have exactly the same elements in them. Set A and set B are both assigned the same elements, one in reverse order of the other. As far as equality is concerned, The order of the elements is not significant, and as long as the same elements occur in both sets, the sets are equal, so set A equals set B. Set C contains only two elements, 8 and 9, and neither of these appear in set A or set B. C is not equal to A, and C is not equal to B. A set that contains no elements is called an empty set. An empty set, designated by A with open and closed curly brackets, is denoted by A equals the symbol phi, which is a circle with a slash through it. A is a subset of B if every element in A is also in B. By this definition, every set is a subset of itself. A set with n elements has 2 to the n subsets. If U, the universal set, equals 1, 2, 3, it has 2 to the third power, or 8 subsets. These are 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and the empty set phi. Often several subsets are based on a single set. If U equals the elements 1, 2, 3, the subsets 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and phi are available. In this case, U is called a universal set. The Venn diagram is an important tool that is often used to help visualize the relationships between sets and their elements. Here, the universal set is defined as the elements 1, 2, 3, 4, and 5. In this Venn diagram, the universal set is represented by all of the elements that are contained within the bounds of the white rectangle, which are the elements 1, 2, 3, 4, and 5. The universal set is assigned the values 1, 2, 3, 4, 5, and 6. The subset A is assigned the values 1, 2, 3. The subset B is assigned the values 3 and 4. The subset C is assigned the values 5, and 6 is not assigned to any subset. The subset A contains the elements 1, 2, 3, and is the red circle in the Venn diagram. The subset B contains the elements 3 and 4 and is represented by the blue circle in the diagram. Subset C containing 5 is represented by the green circle. The element 6 is not assigned to a subset and is shown residing in the white area outside any circles representing subsets. Neither the element 5 or 6 have elements that are common with each other or with subsets A and B. Therefore, elements 5 and 6 are said to be disjointed or mutually exclusive from the other elements in the universal set. From the Venn diagram, it is obvious that element 3 is at the intersection of sets A and B. Also, elements 1, 2, 3, and 4 are at the union of sets A and B, and subset C containing 5 and the isolated element 6 are disjointed from all of the other elements. Although these facts can be determined from the assignments at the top, they are immediately obvious with the diagram. Subset A and subset B belong to the universal set U, and a new subset can be created using the intersection of A and B. The intersection of two sets, A and B, is a set of elements that are common to A and B. In this case, the intersection is the elements 2 and 4, since both of these elements are common to both A and B. The intersection of A and B is indicated by A intersect B. The union of A and B can also be used to create a new subset. The union of two sets, A and B, is the set of elements belonging to A, B, or both. The union of A and B is the elements 1, 2, 3, 4, 5, 6, and 8, since these elements are the union of A and B. The union of A and B is indicated by A union symbol B. Values 2 and 4 at the intersection only appear once in the union and shouldn't be duplicated. U is the universal set and contains the two elements black and white. Set A is defined as the subset of U, which contains the element white. Set B is defined as the complement of A, indicated by A prime. The complement of A prime, is everything in U that is not in A, or in this case, black. Hi friends and neighbors. Thanks for watching ShepNotes video about statistics and probability. This video investigated the nature of sets and Venn diagrams. Watch for the next video in this series.